Okay, in section 4.6, it is the fundamental theorem of algebra. Now, we're not really going to cover the details of the fundamental theorem of algebra. More of that we're going to save for your journey when you hit math analysis. So we're not going to worry too much about this right now. We're going to go ahead and move down, and we have the complex conjugates theorem. The idea behind the complex conjugates theorem right here is similar to that of the irrational conjugates theorem that you guys covered in section 4.5. So I'll show you how to solve those problems in our examples coming up. And the Descartes rule of signs, which is what you see next, that's another thing that will be saved for algebra, or sorry, in math analysis. The basics about Descartes' rule of signs is that based on the signs that are given in the equation, we could figure out how many positive, how many negative, and how many imaginary solutions you will have. But that's not really the most important thing. The main things that we're going to cover today on 4.6 is pretty much what you did on 4.5, and it's more practice on finding zeros of a polynomial function, okay, solving things out. So let's take a look right here at number 1. All right, I've got myself this polynomial with 5 terms. With 5 terms, you can't group. You can't use the quadratic formula. So hopefully you remember that the only thing you can do is find all the possible solutions. And so we got to figure out, well, what are different factors of 60? Okay, and remember, we find different factors of 60 and also find the different factors of the first term, which is 1. So luckily on these problems, where we have P is 60, Q is 1. The Q will be, I'll try to make it so it's 1 so you don't have to worry about so many different combinations, although there do happen to be quite a bit for 60. Because factors of 60, we have 1, 2, 3, let's see, we've got 5, 10, looks like I think 15 is another, and then we have 20, 30, and 60, right? At least for the bottom, there's only 1. So remember, when we put P over Q, we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, etc. All right, because 1 over 1, 2 over 1, 3 over 1, 5 over 1, 10 over 1, 15 over 1. To save you the trouble right here, I know that this one has a lot of combinations. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2 because of the plus or minus. That makes 18. So there's quite a bit. I'll help cut to the chase. My magic ball tells me right here that one of the factors that I should try out, or the solutions, is -2. Okay, so we're going to use our synthetic division. And remember, we're going to go ahead and plug in our coefficients. So we have 1, -3, 6, 2, -60. And let's go ahead and go through the process right here. And trusting the process, like Joel Embiid, we're going to go ahead and drop the 1 once my cursor figures out where to go. And then, so remember, we're going to multiply with what's in the corner. We got -2, and we're adding things up. -2 plus 3, or -2, or sorry, -3 plus -2, we have -5. -5 times -2, positive 10. This adds up to 16. 16 times -2 is -32. So we're left with -30, and -30 times -2 happens to be 60. And we have no remainder. Amazing, that crystal ball that I have. So what do we do next? Don't forget, we know one of our solutions is -2 now. So let's go ahead, we'll rewrite our problem. And so instead of x to the 4th, we now have x to the 3rd minus 5x squared plus 16x minus 30. And so let's think about our options here. I've got 4 terms in our polynomial. Maybe we could group. I'm looking right here, and grouping will not help me out. So what do? I repeat the process that I just did in step 1. So what number should I choose? My magic ball tells me that 3 is a possible solution. So we'll go ahead and put our coefficients down. 1, -5, 16, -30. And let's go ahead and do our synthetic division. Drop down the 1. 1 times 3 is 3. This adds up to -2. -2 times 3 is -6. 16 minus 6 is 10. 10 times 3 is 30. And so right here, we have no remainder. All right, my magic ball was correct. And so we have x squared minus 2x plus 10. All right, so what can we do with the trinomial? We could try factoring, but there's no factors of 10 that add up to -2 that I know of. So what do? We could go ahead. You can complete the square if you like, but why do that? Let's go ahead instead use the quadratic formula. So let's use the quadratic formula here. We got -b, so we got -2 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's simplify this down. -2 is a +2. We got plus or minus right here. -2 squared is 4. 4 minus 40 right there ends up being -36 all over 2. So let's go ahead and simplify this. Remember, we learned about how we cannot have a negative inside of our radical. So we can go ahead and simplify that, and we now end up with 2 plus or minus, and then we got ourselves an imaginary number. So we got 6i. I can simplify this a little bit more. Remember, when we're dividing everything by 2 right here. So that's where a lot of students mess up. They'll usually take 2 divided by 2, and they got 1, and they'll say, oh, 1 plus 6i and 1 minus 6i. That is not the case. You've got to make sure it simplifies to both the 2 and the 6i, because we're dividing everything right there. So my actual answer right here that I will get is 1 plus 3i and 1 minus 3i. Okay, so we have a total of 4 solutions. These 2 right here, we've got -2 as another, and then also +3 as the last one. There are possible right here of 4 solutions. Okay, so one of the things that we once again didn't talk about, but it is part of Descartes' rule of science, that it will tell us how many imaginary and how many real number solutions and how many negative there will be. But why do that when we can go ahead and just solve it out? Okay, so there you have it. There are, and don't forget, another thing to add is that the degree of the polynomial can tell you how many solutions that are possible. Okay, there is a possibility, because this is x to the 4th power, the degree of the polynomial, that we have 4 total solutions, but they're not all real. Okay, they are not all real. Let's take a look next up at number 3. Okay, so with number 1, if you can't factor it, then you got all these different options, right? You have to find the different possibilities to figure it out. And throughout that journey of finding all the solutions, you might have to use the quadratic formula. You might be able to factor. You might be able to group. So there's all types of things that is possible in finding your solutions there. So let's take a look right here at number 3. Okay, on number 3, we have a trinomial. So you want to think, can I factor things out? Okay. I would probably always try to start off with that. Now, even though I have a trinomial, remember, I cannot use the quadratic formula here because the degree of the polynomial is to the 4th power. The quadratic formula is only good if you have x squared, which is a quadratic. So let's hope that this is factorable. I want to see, are there factors of negative 49 that add up to negative 48? And once again, we have this right here. Factors of 49 that add up to negative 48. And if you think long and hard, there actually is one. Those factors right there happen to be negative 49, positive 1. That gets me negative 49. That adds up to negative 48. So then what goes in front right here? Well, if my middle term is x squared, and we have my degree of the polynomial is x to the 4th, what's going to have to go in right here is going to be x squared. Because think about it, if I FOIL this, x squared times x squared, oh my gosh, it's x to the 4th. The outer and inner gets me negative 48x squared, and then the last part is negative 49. Now we are trying to find the zeros, so the last thing is let's take our binomials right here and set it equal to 0. Now, hopefully you recall that this x squared minus 49, hey, look at here. Difference of 2 squares. Our good old friend showing up again. And then we have x squared plus 1, and I can't do anything about that because there's no such thing as the sum of 2 squares. So we take all these, we'll set it equal to 0. I know that x is going to equal to plus or minus 7, right? Setting that equal to 0. Taking the x squared plus 1, set it equals 0. We'll move the 1 over, and then we'll square root both sides. And x is equal to square root of negative 1, which is going to be I. And don't forget, plus or minus I. So remember, the degree of the polynomial is 4. We have 4 total solutions here. Sometimes you'll have all 4, but we have one positive, 1 negative, and 2 imaginary. All right, so sometimes you might be able to factor things out, which is a good thing because it's usually a lot easier than going through all the work that you had to do in number 1. All right, the last thing now is let's write a polynomial function of the least degree that has a rational coefficient and a leading coefficient of 1 and the given zeros. So remember, if these are the given zeros right here, what we're trying to do is write a function of f of x. Okay, and so remember, these we will need to turn and convert into binomials. Well, in order for me to get negative 4, x plus 4 has to be my binomial. Because remember, if I set this equal to 0, that will make this one of my solutions of negative 4. So how am I going to get positive 1? I'm going to have a binomial of x minus 1. In order to get 7, x minus 7. So now that we have our binomials all set up, then what we're going to do is we're going to have to start multiplying. This one we're going to FOIL. Let's FOIL these two right here to begin with. We've got x squared. First, outer minus x, inner plus 4x, last negative 4. And so we got x squared plus 3x minus 4 is the beginning. And then we're going to go ahead and we're going to multiply that by x minus 7. And so you're going to have to do some simplifying right here, multiplying things out. So let's take the x and multiply with x squared, 3x, and negative 4. Let's see here. So I got x to the 3rd plus 3x squared and then minus 4x. And then let's take the negative 7 and multiply it all out. And so we got negative 7x squared minus 21x plus 28. And so the last step right here is to combine like terms. And I have now x to the third minus 4x squared minus 25x plus 28. All right, so x to the third minus 4x squared minus 25x plus 28 is your simplified answer. And there you go. Let's take a look next, up at number 6. Okay, I've got myself a radical. This is where we're going to need to use our complex conjugates, very similar to the irrational conjugates. So let's set up our equation. First off, right here with the 10, we're going to go ahead and put x minus 10. Just like with the irrational conjugates, what I'm going to do here is to start off with x. And so I'm going to put x minus. And in parentheses, let's put what the 0 is, which is negative 5. Okay? And then we're going to go ahead and put right here x minus. That part will stay the same. And then in parentheses, we're going to take the conjugate of it, which will be positive 5 or positive rad 5, like so. All right. So now let's simplify this, and I've got x plus rad 5, and I have x minus rad 5 as a result of all of that. I'm going to multiply this stuff first. Now, remember, just like in the last section, with the conjugates, the outer and inner terms cancel each other out. So all I really need to multiply right here is x times x, the outer and inner, right? And then, so there's the inner, or sorry, the first and the last, right? And then, so the last part is going to get us rad 5 times negative rad 5 is rad 25, which is going to come simplified down to 5. And so now we have no radicals. What happened to the outer and inner terms, you say? Remember, if you multiply it out all the way through, the outer and inner terms will cancel. Because you end up with negative rad 5x, or x, negative x rad 5, and positive x rad 5, which then simplifies to being 0. So now, the last thing is to go ahead and take this and FOIL it out. So we got x squared, outer minus 5x, inner minus 10x squared, and then last is plus 50. So let's go ahead and simplify this right here, and then let's have, let's see. We've got, oh, whoops, sorry, this is supposed to be x to the third. So we got x to the third, all right, and then we got ourselves minus 10x squared minus 5x plus 50, and there you go. We now have this in descending order. All right, let's do one last one right here. Let's try simplifying number 7, putting this all together. So we start off with, for the 8, we've got x minus 8 as one of our solutions. So we have ourselves, once again, we've got some imaginary numbers, so we have to use that irrational conjugates business. And so the first part right here, we got x minus, and then we'll have 3 minus I. Okay, and then I'm going to have x minus, right here, the conjugate of 3 minus I is going to be 3 plus I. Let's deal with this x business over here. And so in this instance, we're going to have to do some grouping. So how am I going to group this out? I'm going to now change this to x minus 3 parentheses minus I, like so. And then with the I right here, we got x minus 3 plus I. Now we're going to go ahead and combine these things together. We'll FOIL this out, and remember the outer and inner terms will cancel. So I'm left with x minus 3 quantity squared, and then I have negative I times positive I. Remember, that's the last part of FOILing, and so we'll have negative I squared. And remember, one of the things we learned were the different values of I to the first, I to the second, I to the third, I to the fourth. And so remembering all that right here, this actually turns into positive 1, right? Because I squared is going to be negative 1, and then so negative 1 is positive 1 right here. All right, and then we have the x minus 8. So we're going to have to go ahead now and FOIL this out or use our pattern. It's going to be a squared, right? Okay, and then it's going to be minus 2 times a times b, so it's going to be negative 6x, and then it's going to be the b term squared, so it's going to be plus 9. And then we have ourselves right here, the plus 1. X squared minus 6x, and then right here plus 10. So now we've got all that simplified. Then we multiply it with the x minus 8. All right, good times right here. And so we have multiplying this all the way through. I'll go ahead right here. We got x to the third minus 6x squared plus 10x minus 8x squared plus 48x, and then minus 80. And then, so in the end, we combine like terms, and we get x to the third minus 14x squared plus 58x minus 80, and that right there is your final answer. And so now you're a pro at solving problems, figuring out their polynomials, coming up with the equations. And that right there is 4.6.